This is Unit 6, and we are on Day 2. Our learning target today is I can write ratios and unit rates. Our vocabulary for today is ratio and equivalent ratios, and that'll be a review from what we discussed previously. And then we're going to extend with rate and a unit rate. So as you remember from our last lesson, a ratio uses division to compare two numbers. Another way of understanding that is it's a relationship between the two numbers, and division is used to explain the relationship. So often when we've compared numbers in the past, we've used greater than or less than or equals to. But this is really a relationship, and so we're going to use division to show the relationship between two numbers. So here's an example. We have 4 hamburgers and 2 hot dogs. So the ratio of hot dogs to hamburgers, if I were to count the hot dogs, I would get 2. If I were to count the hamburgers, I would get 4. So our ratio is 2 to 4. That also can be written 1 to 2. And if we're looking for the ratio of hot dogs to food, well, we have 2 hot dogs, and all total we have 6 pieces of food. So that ratio is 2 to 6, which once again can be rewritten as 1 to 3. Now there are a couple of important things to remember here. In the first ratio, hot dogs to hamburgers, that was a part-to-part ratio. I was comparing part of our objects, the hot dogs, with another part, the hamburgers. In this ratio of hot dogs to food, this is considered a part-to-whole ratio, because part of the whole are hot dogs, and then all of the whole is food. Over here you'll see 3 different ways to write ratios. You could write the numbers with the word to, T-O, in between them. You could put a colon in between them, or you can be writing them as a fraction. They are always read, though, 2 to 4, 1 to 2, 2 to 6, or 1 to 3. It's also important here to remember that, just like with fractions, ratios need to be reduced to lowest terms. So these two are considered equivalent ratios, and these two are considered equivalent ratios. We've looked at this 1/2 as a number, and we've looked at it as a ratio. So let's examine the difference. As a fraction, half often represents part of something. We treat it as if it were a single number. So both the top and the bottom number are referring to the same thing. In this example, there's an apple, and we're cutting it into 2 halves. So half of an apple is all 1/2. We are talking just about apples with this whole fraction. As a ratio, we are looking close at the top number and the bottom number because they use different things. So an example of a ratio might be 1 square to 2 triangles. And that would be a ratio 1 to 2, which looks the same as a fraction and can be written the same, but they have slightly different meanings. So now let's talk about rate. A rate is a ratio that usually involves a period of time. So for example, we have a car and it's traveling 40 miles per hour. Now you might say 40 miles per hour, that's not 2 numbers. We're supposed to have 2 numbers to compare, but we really do. We have 40 miles per 1 hour. In this example, miles to hours, this is a rate because we can travel 40 miles to 1 hour. Another example of a rate would be 6 miles of walking in 3 hours, or 40 words typed in 2 minutes. And the last example would be 1,200 miles traveled in 4 days. These are all ratios. They are all also rates because they involve a period of time. So let's look at an example. It says lightning strikes about 100 times per second around the world. about how many times does lightning strike per minute around the world? Well, we said 100 times per second, which is how many times per minute? Well, if I multiply both the numerator and denominator by the same number, then I can make this an equivalent rate. So 1 second, there would be 60 seconds in a minute. So if I multiply the numerator by 60, I get 6,000 times per minute. So lightning strikes about 6,000 times per minute around the world. Again, the key concept here is that we needed to create an equivalent rate with a different amount in the denominator. So we just multiplied the numerator and denominator by the same number, just like we were if it were a fraction. So let's try a couple of them. We have 150 heartbeats in 2 minutes. How many heartbeats then occur in 1 hour? Now remember, there are 60 minutes in an hour. Okay, if there are 60 minutes in an hour and this is 2 minutes, if I take 2 times 30, I'm going to get 60 minutes or 1 hour. So if I take the numerator times 30, I get 4,500 heartbeats. Next, we have 6 kilometers in an hour. Somebody's walking 6 kilometers in an hour. And we want to know how many kilometers they walk every minute. So again, we have 60 minutes per hour, but this time we're going a different way. We're going from hours to minutes. So if I did this one, I would divide the denominator by 60 and divide the numerator by 60. So I would get 0.1 kilometers. Now if I extend this idea and I try to find out how many meters that person would walk in a minute, I convert kilometers to meters. If you'll remember, there are 1,000 meters in a kilometer. So if I multiply this by 1,000, I will find the number of meters. Now we're not making equivalent rates here. What we're doing is we're converting meters and kilometers. Kilometers times 1,000 would give us 100 meters. Okay, so let's talk about unit rate. A unit rate is a rate that has a denominator of 1 unit. So you might have 24 hours in 1 day. That's a unit rate. $12 per hour. That's a unit rate. 10 meters per second. And 162 games per year. Those are all unit rates. They're rates because they involve time, and they're unit rates because the denominator is 1 unit. So a unit rate is a rate that has a denominator of 1. To write a unit rate, we find an equivalent rate so that the denominator is 1 unit. We often use unit rates to compare two things. So for example, if the red car goes 120 miles in 3 hours, and the green car goes 150 miles in 5 hours, which is going further in the same amount of time? Well, if I have 120 miles in 3 hours, I can divide by 3, so I get 1 hour in the denominator, and it can go 40 miles in an hour. The green car is 150 miles in 5 hours, so if I divide both the numerator and denominator by 5, I will find that in 1 hour it can go 30 miles an hour. So the red car can go faster than the green car. We had to get both of them to the same unit rate of 1 hour to be able to compare them. Okay, let's have you try a couple. You're trying to find the unit rate for 72 words in 3 minutes and 58 miles with 2 gallons of gas. And last, tell me something that you learned or were reminded of and a question that you have.